Hello everybody, and welcome to section 5.1, which is entitled Two-Dimensional Vectors. Uh, section Chapter 5 deals with forces in two dimensions, so you're not just pushing up and down or left and right, you're pushing up and down and left and right at the same time. The first thing that you have to know to be able to succeed in this chapter is some trigonometry. And this thing called SOHCAHTOA. SOHCAHTOA stands for sine, cosine, and tangent. So I don't know if you've heard this or not, I don't know where you are in your math journey, but the sine of any angle, I'm just giving it the Greek letter alpha. So for instance, let's just call this alpha. The sine of alpha is always equal to the opposite. That's what O stands for, the opposite, over the hypotenuse. The cosine of alpha is equal to the adjacent over the hypotenuse. And then lastly is the T, it stands for tangent. The tangent of alpha is equal to the opposite over the adjacent. So let's just say I've got a triangle here, and this sine, cosine, and tangent only works in right triangles. It only works in a right triangle. And I'll just give you a quick right triangle. So maybe I know that this is 6, this is 8, and this is 10. These are a Pythagorean triple, like 6, 8, 10. So I know that these work, they make a right angle. So for instance, if I wanted to say the sine of alpha, remember the sine is the opposite divided by the hypotenuse. The opposite is always the side that's directly across from your angle. So the opposite of alpha would be 6. And the hypotenuse would be 10. And then you go to the cosine. So if we went cosine of our angle alpha, the cosine is the adjacent, so that's the one right next to it, 8 over the hypotenuse, 10. The tangent of alpha would be the opposite, which would be 6, over the adjacent, which would be 8. Now, one more thing that goes along with finding the angle. So, like, let's say I wanted to actually figure out, I wonder if I could figure out what this angle actually is right here to make this work. So I've got this triangle that's 6, 8, 10, and I wanted to actually figure out what this angle is. What I would do, I could take any one of these three equations and I could move the sign to the other side of the equation. So I would say that alpha equals, and we use what's called the inverse sign. The inverse sign of 6 over 10. Or you could use this one. I could move the cosine over to that side. So I could say that alpha equals the inverse cosine of 8 over 10. Or I could use this one, move the tangent over, and alpha would equal the tangent of 6 over 8. Now, if you use your calculator, if you wanted to pull your calculator out, you can, and you'll look at right next to cosine, sine, cosine, and tangent on your calculator. If you hit second function, you can do the inverse cosine and inverse tangent and inverse sine. So I could do the inverse sine just to show you what it actually would be. So I hit inverse sine of 6 divided by 10. And it ends up with 36.9 degrees. So this would be 36, all of these would be equal to 36.9 degrees. The only other thing that you have to look out for is to make sure your calculator is in degree mode. You make sure it's in degree mode. In a lot of the Texas Instrument calculators, if you hit the mode button and just look to see if it's in degrees, because if it's in radians, when you do these problems here, this isn't going to be degrees, it will be radians. And it's not wrong, it's just you have to make sure that you're getting the right units. So in order to do a lot of these questions today and for the rest of the semester, we're going to have to kind of draw upon our knowledge of trigonometry and sine, cosine, and tangent. There's a couple other things that will help us. The Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. There's this thing called the law of cosines, and it's like the Pythagorean theorem because you've got a squared plus b squared equals c squared, but you've got this other thing. It says 2ab cosine c. Now, the Pythagorean theorem will only work right triangles. The law of cosines is in any triangle. So sometimes if your triangle is not a right triangle, this might be your horse. The law of sines says this. It says it's the sine of angle A divided by side A is equal to the sine of angle B divided by side B, which is also equal to the sine of angle C divided by side C. And again, this will work in any triangle. These are in your book. These descriptions of what they are, they're just in words, in sentence form, exactly what the law is. So let me give you our first example. It says, find the magnitude, and the magnitude means how big, of the sum of a 15-kilometer displacement and a 25-kilometer displacement when the angle between them is 90 degrees and when the angle between them is 135 degrees. So let's we're going to do two problems here. We've got a 15-kilometer displacement, so I'm going to go like this and say that it's 15 kilometers. And then I've got a 25-kilometer displacement. Maybe I'll make this down a little bit further just to make my 25. I want to make it kind of roughly to shape, 25-kilometer displacement. The sum, when you take vectors and you add them, so I've got these two vectors, we do what's called adding vectors tip to tail. When you have two vectors, what I'm going to do is I'm going to take vector A, which is 15, and I'm going to add on to it vector B, which is 25. The resultant vector, the net force, the net vector of the resultant, the net displacement in this case, the resultant vector will go from the beginning of your first vector to the end of your last vector. And you might say, well, what if I started with adding the 25 to the 15? You'll notice that the resultant is the exact same thing. It doesn't matter what order you add them. Then the question wants to know, how big is this resultant? So in this case, because they tell you that it's a right angle, then you're just going to use the Pythagorean theorem. You're going to say a squared plus b squared equals c squared. So if you take 15 squared plus 25 squared, take the square root of it all, and you get 29 kilometers. And what about if we took those same two vectors (15 and 25), except now the angle between them isn't 90, it's 135 degrees. So which is like, it's about 45, it's 90 plus 45 degrees. So here's my 135 degree angle. And it wants to know this, the resultant. Now, some places where I see people always making their mistake in this chapter is that when you have two vectors, they'll sometimes add them tail to tail. And what I mean is this. They'll put this right here, end to end, and they'll say, oh, I got to find this angle. And you can see very easily in this case that this resultant right here that you would find is not going to be the same as this. They're nowhere near the same league as each other. You're going to get totally different numbers. You're going to get totally different directions. They aren't even going to be close to one another. So make sure that when you do it, you add them tip to tail. On the tip of one vector, I put the tail of another. And so my resultant goes right here. So this is my resultant. I think maybe you want to try to use the law of sines and cosines. You don't really know which one will work, but when I look at this, I'm going to use the law of cosines. And the law of cosines says this. It goes a squared plus b squared minus 2ab cosine angle C equals c squared. This is going to be my side A. This is going to be my side B. And this is going to be my side C. It doesn't matter which one is A and which one is B. You can put A and B. They are interchangeable. But what's not interchangeable is C. C has to be, you see how this is the angle that I know? C has to be always across from the angle that I know. So in this I would say 15 squared plus 25 squared minus 2 times 15 times 25 times the cosine of 135 equals c squared. So you can do that all in your calculator. 15 squared plus 25 squared minus 2 times 15 times 25 times the cosine of 135, and you get a big number, 1,380. So then to find c, I got to take the square root of both sides. So I take the square root of this, and I get 37. And you ask yourself, does that seem like it's about right? I think so. I mean, I know that the biggest that C could be is if I took A and then I made it straight. So the biggest it's going to be is 40. So I know that it has to be less than 40, and I know that it has to be more than, if I went the other way, if I went 15 up and then 25 up and 15 back, 10. So I know that this resultant always is going to be between 10 and 40. 37 fits the bill pretty well. Life is good. The next type of problem, here's another example. Finding your way home. It says a GPS receiver indicates that your home is 15 kilometers and 40 degrees north of west. Oh boy. So what I'm going to do, I'm going to make kind of a compass rose here. This is north, south, east, west. That your home is 15 kilometers and it's 40 degrees north of west. So I go north of west. So here's west right here. And then I go 40 degrees north of it. See how I went 40 degrees north of west? So here's my 15, if I made this 15 kilometers, here's where my home is. So I'm going, and that's a tricky thing for people to understand, the whole north of west. What if it said west of north? Well, then you would go north first, and I would go west of it, 40 degrees. So that would be here. And that they are two completely different directions. So the whole north of west and west of north thing, north of east, east of north, south of east, east of south, west of south, south of west. They're all 8 different things. Okay, but the only path through the woods leads directly north. If you follow the path 5 kilometers before it opens into a field, how far and in what direction would you have to go to reach your home? So I know I got to get here. I end up going 5 kilometers. And the question is, how far and in what direction do I need to go to get there? So there's a couple ways I can see to do this problem. Way number 1, and that's what I'm going to do. I'm going to break this down into 2 different ways. Way number 1. I think I could probably use the law of sines maybe, or the law of cosines. So what I've got here is I basically have a triangle that's looks like this. I've got this triangle. I know that this is 5. I know that this is 15. And I know that this is 40 degrees. So that has to make this angle right here 50 degrees, because it has to add up to 90 right there. So my ultimate goal is to figure out this. So I think what I would go, maybe the law of cosines would work really well for this one. Because I would say, I would go, I'd have to declare which one is A, B, and C. So it's it goes like this. It goes A squared plus B squared minus 2AB cosine C equals C squared. So I think what I want to do, remember that C, whatever side I decide to make C, C always has to go across from the angle you know. So that has to be C. This has to be A and B. And remember that A and B, it doesn't matter. Those ones you can switch around, but C has to be that one. So I would say 5 squared plus 15 squared minus 2 times 5 times 15 times the cosine of little c equals, I'm sorry, I actually know that little c. That little c is 50. That equals c squared. So I could do that. So I take my calculator. 5 squared plus 15 squared minus 2 times 5 times 15 times cosine 50. Then I take the square root of that, and it comes out to 12. 12.4. How many sig figs can I have? Looks like 3 sig figs, so 12.4. There's the first part. That's how far I have to walk, because the question wants to know how far and in what direction. So what I'm going to have to do is I'm probably going to have to find, I am going to have to find this angle. And again, I'll just call it alpha. In science, in math, that's what we do. We name angles Greek letters, and we name straight line distances English letters, just so we can keep them straight when we start looking for stuff. I think what I'll do now is use the law of sines. And so the law of sines goes like this. It goes the sine of A over the side equals the sine of B over the side. So what I'll do, I'll just say the sine, and I'll pick an angle that I know, the sine of 50 over, and then side A. So if this is A, then I have to use, that's the side A. So that is 12.4. The sine of, I'm looking for that angle alpha, over side B. So that's going to be 15. So I cross multiply the sine of 50 times 15. So 15 sine 50. That equals 11.5. And I do this, and it comes out to 12.4 times the sine of alpha. I'll divide both sides by 12.4. So 11.5 divided by 12.4 is 0.927. And then I have to move the sign over. And remember how we do that? You do the inverse sign. So I take the inverse sign of this. And you get 68 degrees. So I got to be careful. I want to walk. So I know this angle is 68 degrees. This is 68 degrees. So that means that, let me just redraw this little triangle here. So if this is 68 degrees, I know that that's 68 degrees west of south. Because here's south, and I got to turn west of it. So that's 68 degrees west of south. I could also say, well, so that if, well, it doesn't really, it's trick. I didn't really draw a very good picture here. So 68 degrees west of south. I could also say 22 degrees south of west. That would be along with that. I think I'm going to leave section the way number 2. Way number 2, that's called components of vectors.
Just a reminder, all them fans, we have volleyball fan bus and a football fan bus. Tomorrow the volleyball fan bus will be free
For another lecture.